Good morning, ladies and gentlemen. I'm Roger Cook, Technology Manager for Petkus in Asia and Australia, and it's a pleasure to come here to VigTam and the Grappers Conference and speak to you today. Who's Petkus? Petkus is a 160-year-old German company. Petkus claimed to have invented the world's first ever mechanical seed cleaning machine right back in 1852, and have very much today evolved to be the technology leader in seed processing plants. So many of you may not have heard about us in flour and feed, but we're one of the world leaders in construction of seed processing plants. So this is the Petkus Group today. I'm running out of room a little bit on this slide. We keep adding more companies, but Petkus Technology is our seed and grain equipment design and production company. So this is the company that's making the cleaning machines and the conveying equipment that we'll talk about today. Petkus Selector is our new company we just bought in Holland. Selector are making fine seed processing machines. So machines for processing tomato seed, cucumber, cauliflower, this kind of thing. MMW is our flour milling equipment company. So MMW are building all the flour milling machines, roller mills, plant sifters. But MMW really specialise in industrial flours and industrial flour for starch. So not so much bread flour and semolina mills. Semisa is the Spanish company we bought 2 years ago, and Semisa is a silo construction company. So Semisa are making everything from small silos right up to huge port terminal silo complexes. Petkus Engineering is our turnkey company, so a lot of the projects we build are turnkey, and that means complete turnkey, including the groundworks, building the offices, the whole plant. And all this is backed up by Aruba, who are our R&D company. Petkus spend a huge amount of money on research and development, and really re-looking at machines which have been traditional machines and seeing how we can do things better, or more importantly, seeing how we can do things differently. So here in Asia, or here specifically in Thailand, our office is on Sukhumvit Soi 42, down here in the city, which is where we're looking at looking after the engineering for Thailand and Southeast Asia. And then we also have a small factory that we established out at Chonburi. The factory at Chonburi is really just doing standard sheet metal products for our corn cob drying houses, and some standard elevators and conveyors. So that's our operations here in Thailand. So today I wanted to talk to you about what's new in grain preparation for milling. As we heard in the first presentation, grain is affected by diseases. Grain is under attack. From the moment it's harvested, insects try to eat it. Rats and mice try to eat it and then leave their evidence behind. We have fungus, we have high humidity, we have damage from materials handling, from our conveying systems. And so really we should focus more on what we can do to avoid grain losses. Why? Well, this is why. The United Nations feels that more than 20% of grain is lost year on year due to spoilage. And in a world which is ever growing in population, and particularly ever growing in demand in Asia, can we really afford to be losing this much grain from our supply chains? The other important point is that one of the key things that affects our grain is broken grain and damaged grain, because insects love broken grain and damaged grain as a food source. So this slide shows the confused flour beetle survival in broken wheat and in whole wheat. So you can see clearly, if we can remove our broken wheat before we put it into storage, we can save a lot of damage to our grain. So how can we do this, and why should we do it? Well, growing demand in Asia in particular, of course, wheat now is a really growing product in Asia, and particularly growth in demand for high quality wheat. We have Tesco here, we have Carrefour, we have the American chains, and these are demanding high quality, clean wheat. So, the importance of pre-cleaning, it's clear. If we can improve the grain before it goes into our silos, before it goes into our systems, we can have safer grain, we can have healthier grain, and we can have less spoilage. So what has Petkus done about it? Well, this is the flour miller's traditional friend, I guess. The standard milling separator, machine which has been around for years. I guess one thing about the standard Petkus machine that you'll see here is that it's galvanised construction. So against a machine which is painted, it gives you more chance to install it not exactly outside, but in silo conditions and places where a machine that was painted would perhaps show some bad signs rather quickly. So, traditional machine, as you're all familiar with, 2 sieve layers, round about 60 tonnes an hour on pre-cleaning wheat, and aspiration channel at the end, which needs a fan somewhere between 7.5 to 11 kilowatt. We're all familiar with this kind of machine. So what to do about it? How can you even make this simple machine better? Well, what Petkus did was say, well, let's make a double deck machine, because the aspirator on the end is the machine that's using all our energy. So if we can increase our sieving surface within the machine and still use the same aspirator, we can get double the capacity for the same amount of floor space in the mill and only the same air consumption on the aspirator. So that then takes our machine, we split the feed at the inlet 50-50. We have oversize and undersize separation, oversize and undersize in parallel. So through that we get 120 tonnes an hour capacity for really no difference in energy consumption. So last year we thought, well, that's great, what else can we do? So we said, well, why not make it the double machine? So this is the SM72 cleaner that we launched last year, and you see this has 8 sieve layers, over, under, over, under, over, under, over, under. And then going into, again, into an end aspirator. The end aspirator does need a little bit more air on this size machine. Perhaps we've got a 15 kilowatt fan. But I guess the important point is, in the same floor space, we've now got a 240 tonnes an hour pre-cleaning machine for very little additional energy. So that's what we can do on our standard flour mill style cleaning machine. But if we really want to go to proper cleaning, we perhaps should look at the technology that we use in seed cleaning, which is a machine that reciprocates rather than vibrates. So with a machine that reciprocates, the sieving action is much better. In our milling separator, the machine is shaking about 1,000 times a minute, and that makes it very difficult for the grain, particularly the small grain, to fall through, because when the grain is falling through the hole, it gets hit by the sieve coming back in the other direction, and so it's hard to get through. When you go to a proper seed cleaning style machine that's using flat sieves, then the reciprocation is only about 300 revs a minute, and so the grain has a much easier chance to fall through. So this is our big V cleaner. This is 150 tonnes an hour on wheat. So again, we split the feed 50-50. We have pre-aspiration at the inlet, so we're really trying to remove a lot of the fine dust before it even hits the sieves. Then we have our coarse oversize scalping, our main oversize, and our fine separation in 2 lots of parallel. Now, one thing you will notice on this machine are this scraper mechanism here, and this is really important on our pre-cleaners. So the sieves are cleaned with ball cleaners, like just about every other machine you might find, but on the top we have this motorized scraper assembly, and that looks like this. And so while the grain is going down the screen, these scrapers are running down the screen and positively cleaning the screen. So if we get any sticks or any stalks stuck in the screen, particularly when we get to the end of the silo, this is positively keeping the screen clean. And we have some great applications showing this. I have a machine in Australia I installed last year on canola for oilseed crushing, and they buy the worst canola you've ever seen. And when it gets to the end of the truck, it's just straw. It's just straw. And yet with this machine, we can still pre-clean at 100 tons an hour of canola without the screens getting blocked. So it makes a huge difference to efficient pre-cleaning when you have the scraper assembly. So that's a bit about some new mechanical cleaning from Petkus. Should also talk about our optical sorting technology, because of course when it comes to mycotoxins and fusarium, it's a very important consideration. The Opto Selector is a machine that we developed from scratch about 5 years ago, and I was actually part of the development team for that. But this year we made some changes to the machine. We've made it higher capacity. We still have a machine which is based on real imaging NIR, so full colour. So when you're sorting, on the screen you see here on the machine, you actually see the real colour images of the grain going through the machine. And this is what the machine sorts on, the real colour images. We also have the NIR, in-gas NIR. That's really useful where we have, for example, sclerotia in sunflowers, when it's black in black and you can't detect it with the RGB technology. And then we have, new for this year, the transmission sorting, and I'll explain a little bit more about that in a moment. So as well as our full colour, we have geometric sorting, so we're able to analyse the shape of each grain as it goes through the machine. And what we have with our machine is not just a basic length and width like you might find on many machines. We have a definite geometric recognition where we can actually enter definite geometric values of square millimetres for the area, millimetres for the length and the width, and functions for some of the other symmetry of the grain. On the NIR sorting, some of you may know that NIR technology on colour sorting has been very difficult. To make any changes on NIR typically needed an engineer with an oscilloscope and guesswork. Yeah. So we said, well, let's try and do this better. Let's try and do this better. And so what we've developed is an NIR technology which is based on real imaging. These cameras come out of the US, the military grade cameras out of the US, and we're actually able now to use real imaging for our NIR settings. So no more oscilloscopes, no more specialist engineer. Of course, what you see is a black and white image because it's a single wavelength. But by being able to see the NIR image and compare the contrast from good material and bad material, we can fully set up the NIR based on what our own eye sees and no oscilloscopes. So, one thing I haven't mentioned about our machine, which is the fundamental difference compared to every other machine you'll hear about. The way we set our machine, we put about 10 kilos of clean material into the hopper. Doesn't have to be perfectly clean, reasonably clean. And then the machine self-learns the good colour, okay? And then when we're sorting, the machine looks at each object and checks to see if it matches the good colour. Very different technology. No more do you need a setting for brown sticks, for black sticks, for white this, for green this, for this. You know, and the problem in food when you have a machine like that, when a piece of orange plastic goes through, if you have no setting for what to do with that orange plastic, likelihood is it just goes straight through the machine. So with this different calculation, teach the good, reject the rest, check, is the object the good colour, you suddenly have a machine which is much easier to set up, much easier for the operator, and a machine which is able to handle the unexpected. So very different technology. New, and I think really quite exciting in the last 3 or 4 months, has been our development of this transmission sorting. So we have very bright lights in our machine, and what we've been able to do is, rather than reflect the light off the grain, we're able to shine the light through the grain and then analyse the image of the light as it's passed through the grain. So effectively we can see differences hidden in the grain. So this, for example, is soft wheat in durum wheat, and we can actually see that there's a difference with the way the light travels through the grain. And so using this transmission technology, now we're able to separate soft wheat in durum. The other big one that's really causing a stir is we're able to separate popcorn in dent or field corn. So forever the popcorn producers have had a real problem when you get normal corn in popcorn, how to get it out. It's the same colour from the outside, it's the same size, it's the same density. But when you look through, there's actually a very big difference in the way the light passes through the machine. So that's a really quite exciting technology that we've just developed in the last 3 or 4 months. So of course, back to broken grain. What causes broken grain? Well, material handling. In particular, we get dust, we get breakage, we get damage. So when we're designing our site, we should just consider how far do the trucks have to go around the site, how far are our conveying distances, what kind of bins are we going to use, what kind of elevators, what kind of conveyors. And so of course there's lots of things you can do. The first thing is, when the grain's delivered to your site, is remove the dust. Why send all that dust into your silos and into your plant? You're not going to make any flour from it. So really, good aspiration at intake is immediately taking out a lot of your problems. Secondly, conveying systems. Well, as I say, Petkus do everything from small farm bins up to huge port terminal type silos. And conveyors up to 900 tonnes an hour. But of course, even then on conventional machines, we should look at what we can do with those. So one thing that's becoming quite popular now is when we run across the bins, for example, the bins that you just heard about, rather than using mechanical drag conveyors, using belt conveyors with movable trippers. And when we have the belt conveyor, we have much less breakage than we have with drag conveyors. So for sure, in a seed plant, we would never use drag conveyors. We would always use the belts. Other interesting development is, I guess, a take on slow-speed bucket elevators. So what we've done is we've developed this special elevator head, and it has 2 pulleys, and the pulleys change the angle at which the material is discharged. So in a normal bucket elevator, your discharge is by centrifugal force, because your belt's at about 2 to 2.5 meters a second. When you change the angle of the discharge in the head, you can run your belts much slower without the need of having the special gravity discharge buckets. So that's a really simple addition, very cost effective, not a lot of extra money. I have a lot of these running in Australia on peas and beans, and when you break the peas and beans, they're worth nothing. But with this new discharge, you really get no breakage. And then, of course, the ultimate in materials handling, the pendulum bucket elevator. I mean, this is the solution to gentle handling. You've got individual buckets. The bucket speed is very slow, and of course completely self-cleaning. And that's a trend we're seeing now, is people moving in critical applications towards these pendulum bucket elevators. So lots of solutions there for re-looking at traditional mechanical handling. And I guess that's the important message from today. There's lots of things that we can do to better handle our grain, to better process our grain. And when we do encounter a problem, there's new technologies to solve problems that we never thought were possible before. Thank you very much for your attention.